Mark van Ramstunk is a respected theoretical physicist at the University of British Columbia. He still remembers his first quantum field theory class as a graduate student at Princeton University. The professor walked in, looked at the students, and asked, "What is a particle?" A student who had previewed the course material answered, "An irreducible group." The professor treated the definition as common knowledge, skipped any explanation, and launched into a series of bewildering lectures. This was the standard answer for those in the know. Profound response. A particle is a representation of a symmetry group A. Symmetry group is a collection of symmetry transformations. Similarly, electrons, photons, and other elementary particles remain unchanged under the actions of certain groups. In other words, particles are representations, which encompasses the 10 ways of moving in continuous spacetime, meaning particles can translate through three-dimensional space and one-dimensional time, as well as rotate or accelerate along the three spatial directions. In 1939, the mathematical physicist Eugene Wigner defined particles as the simplest objects that can move, rotate, and accelerate. He realized that, for an object to properly undergo these 10, it must possess a minimal set of properties, and particles have these properties. The first is energy, which, at a deeper level, is the property that remains unchanged as an object evolves over time. The second is momentum, the property that stays constant as an object moves through space. To describe how particles change under combinations of spatial rotations and accelerations, i.e., rotations in spacetime, a third property is needed: spin. In Wigner's time, physicists already knew that particles have spin, intrinsic angular momentum that determines whether a particle behaves like matter, such as an electron, or like a force, such as a photon. Their degrees of freedom related to spin, each of which can be thought of as a label attached to the particle, vary in number. For example, some particles have 3 rotational labels, meaning their rotations resemble those of three-dimensional objects. All matter particles with 2 spin labels, spin up and spin down, rotate differently. Take the electron as an example. Much like rotating an arrow once around the two-dimensional, nature also includes elementary particles with 1 or 5 spin labels, but none with 4 seem to exist.